Homework 4.1, Exponential Functions, Video 7. Homework due Friday, May 29th at 11:59 p.m. This video, and I think I'll do one more because I'm going to do two examples, is associated with homework questions 8 through 11. In the previous video, we used Desmos to discover the actions caused on a graph by adding a number or subtracting a number from the end that caused a vertical translation up or down as you would think, pluses up, minuses down. Adding or subtracting a value directly to the x that causes a horizontal translation left or right, but the opposite of what you might expect. Plus actually moves it to the left, minus moves it to the right. And then the insertion of a negative either in front of the function or on the x. A negative in front reflects the graph across the x-axis, but a negative on the x reflects it across the y-axis. And we can use those transformations to sketch the graph of a function without making a table of values. For example, let's say we want to graph the function f of x equals 3 to the x minus 6 power. Before we talk about how the graph moves, let's look at the graph without the minus 6, so just 3 to the x. Now we know that this graph has a y-intercept at 0, 1, and its base point, the point whose y-coordinate is the base, is 1, 3. So because the base is greater than 1, it starts out low, hits the intercept, hits the base point, and then accelerates really fast. And this graph has a horizontal asymptote at y equals 0. But that's not the graph we want. The graph we want is the graph of f of x equals 3 to the x minus 6 power. So to find it, we have to start with the graph that we're going to move and then move it according to this list of transformations. What effect will this minus 6 have on that graph? If you subtract a number from the exponent, it moves the graph to the right 6. I hope I have enough room here. So this is going to cause a movement to the right 6. So we have to move everything to the right 6. Let's start with the y-intercept. If the y-intercept is at 0, 1, and we move it to the right 6, where will it end up? Well, if it's here and we go to the right 6, it'll be here, and that's the point 6, 1. Where will the base point move? Moving to the right 6 basically adds 6 to the x coordinate. So if I add 6 to 1, I get 7. It will be over 7, up 3. And every other point moves as well, but we only keep track of those two. Now where does the horizontal asymptote move to? Well, if you move this horizontal line to the right 6, it's going to be the exact same place. So the horizontal asymptote is also y equals 0. Okay, that didn't take a whole lot of time. I do want to show you, however, in the homework, how to draw this graph, because in the homework it will ask you to enter the graph. So, let's go look. In Desmos, no, not in Desmos. We're not discovering how to graph these, I'm showing you how to put them in the homework. Now, it may have timed out on me because it's been sitting here for quite a while. I'm not sure. Main menu, homework. Let's see here. Let's go down to 4.1. And let's go to question 8. That's where these graphing questions begin. Let's blow this up. Okay. Notice that this question is asking me what it does, and then it asks me to do the graph, but in order to get to the graph, I have to get past this, although this one's different than the one we did. What does the plus 6 on the x do? That would move it to the left 6. So let me go ahead and say shift 6 units to the left so that I can get past this. Check answer. I should be checking the answer. Where's check answer? Oh, there it is. Okay, let's get past that. And now to draw the graph. Let's blow up the graph. Let's export it out of here. Okay. So to draw this graph, the first thing we have to do is click a tool. This one says Exponential Tool, so that's the one we're going to click. Now it says click the graph to plot your curve. It doesn't say where to click, just click it. And when you do, watch this. Notice that it already throws an exponential function up there, but then this little controlled box pops up. There are numbers you can insert for vertical stretching or shrinking and horizontal stretching or shrinking. I've chosen not to focus on those, so we can skip those and leave them at 1. By the way, those occur when you multiply numbers or divide, as opposed to adding or subtracting. But here we have sliders that indicate translations. So vertical translation, we slide it left to go down and right to go up. Horizontal translation, we slide it left to go down and right to go up. Notice it already defaults to the correct base here, so there's no need to change it. And there are buttons to click for reflections. Now, our graph moved to the right 6. So if I wanted to move this to the right 6, that is a horizontal translation. You would click and drag until it gets to 6. And you notice it's telling you where you are. So watch the yellow graph. I'm going to go back to the center. This is like a slider in Desmos. I think it's where they got their inspiration. So slide it to the right, and there it is. Now, in order to get this one correct, remember this was 3 to the x plus 6, so it would actually go to the left 6. So in order to get it correct, I'm going to slide it to the left 6. And then we'll save it, and then we'll check it, and then it's going to tell me that it's wrong, and I know why it's wrong. Anytime it tells you it's wrong, you might want to read this. Use the transformation determined in the previous step to graph the given function. Recall that the asymptote is the equation in the line, blah, blah, blah. Be sure to graph the asymptote using a dashed line. Wait, graph the asymptote as a dashed line? I didn't even know I was supposed to graph the asymptote. Graph this and its asymptote. Use the graphing tool to graph the function as a solid curve and the asymptote as a dashed line. So the reason it's counting it wrong isn't because I put the graph in wrong, it's because I didn't do everything it asked. So let me blow this up again, and I'm going to show you how to draw the asymptote. It's a line, so you just click on the line tool. But you'll notice that it said it wanted a dashed line. Right now the solid button is pressed, so if I press this, now it's going to make us a dotted line. Let's pretend you didn't catch that. And you want to draw the horizontal asymptote. Just click any 2 points on it. Since it's the x-axis, we just need to click 2 points on the x-axis. Oops, my line went astray. Let me click and drag this point where it belongs. And if I save it and check it, it's still going to tell me it's wrong, even though it's the correct asymptote. But you graph the asymptote incorrectly. Actually, the reason it's wrong isn't because the asymptote is in the wrong place. Do you know why it's counting it wrong? Asymptote is a dashed line. So how do you make the line dashed after you draw it? You select it, and then press the dash button. And now it should count it right. I tell you what, I was going to stop and make another video to do another problem, but since we're here in Desmos, since we're here in the homework, let's just do one here. So let's see which one of these I want to do. I haven't completed the question. Oh, it wants the equation of the asymptote. Okay, the equation of the asymptote was y equals 0. Can I go now? Am I done? Oh, there's one part remaining. The domain is, I just want to go to the next question. If you notice, I'm not reaching over to go infinity. I know the keystrokes for infinity. In fact, if you hover over something like this, it'll tell you the keystrokes for typing something in. Because I know how inconvenient it is to move your hand all the way from the mouse to the keyboard. Are we done now, or do you want the range? Of course you want the range. All right, fine. Range is 0 to infinity. By the way, if the graph moves up or down, it'll change the range. Think about it. Okay, can we now go to another question, please? Thank you. I guess I could have gone, but I wanted to get it complete. All right, so wait, I skipped number 9. So let's just talk about this one. 3 to the x power minus 3. What would the minus 3 do to the graph? Do you remember? Subtracting a number from the end moves the graph down. So this would be the same, except it would move down. But let's go to one that has more than one transformation. Let me check the last one. That one's easy, it's just a negative, it invokes a reflection. So let's take a look at this one that has 2 actions to it. We have a minus 2 in the exponent, and a minus 2 in the exponent will move the graph to the right. That seems backwards, but it does. And a minus 2 at the end will move it down. So I got to click both of these. Again, I'm just doing what this says to do. All right, so let's check that. Fantastic. You can press the enter key to submit answers. Graph this in its asymptote. Okay, so let's graph it. And notice that I didn't click this. You can actually do the graph inside the question. So, exponential tool. Click the down here, it's telling me what to do. Click the graph to plot your curve. Here comes the pop-up. We're not doing any stretching and shrinking, but we did say that this moves to the right 2. So we need to take the horizontal translation and move it to the right 2. Okay. And we also said it moved down 2, so we need to take the vertical translation and move it down 2. Okay. Now, because the graph moved down 2, so did the asymptote. So, to draw the asymptote, click the line tool, and you can kind of tell the asymptote, well, the asymptote went down 2 also, so it's 2 below the x-axis, but remember that at one of the asymptote is a dash line, so now we can check it, and we're good. All right, I'm not going to answer the rest of the questions because we're already at the 12:30 mark. Well, I'm not going to type them in, but the equation in the asymptote is y equals -2 because it was at y equals 0 and then it went down 2. The domain is still negative infinity to infinity, but because the graph moved down 2, the range now starts at -2 up to infinity. Just remember that it doesn't include -2 because of the asymptote. And that's pretty much all there is to this assignment. It's only 11 questions, and it's actually a pretty easy one. The remaining homework assignments in Chapter 4, there are 3 of them, will involve logarithms, which is the answer to the question, what is the inverse of an exponential function? Just a reminder, if a graph passes the horizontal line test, it has an inverse. All exponential graphs will pass the horizontal line test, so all exponential functions, well, all simple exponential functions have inverses, and the question is, what are they? That will be answered in the next series of videos. Good luck, and if you have any questions on the homework, you know how to reach me. I guess I can stop the video.